Hi, my name is Spencer Roy. I'm going to be going over the breadboard connections and the GUI implementation of our pendulum swinging project. We just have a simple free swinging pendulum right here that is used to collect all of our data. And right here, the white wire is connected to the trigger pin on our ultrasonic sensor, which is connected to pin 7 on our Arduino. We also have this orange wire connected to the echo pin, which is connected to pin 6 on our Arduino. We also have an RGB LED connected with 2 resistors to prevent it from burning out. And we have these red and green wires connected to pins 9 and 8 on our Arduino to control the color of the LED. And then we also have some universal ground and 5-volt inputs on the breadboard, which is connected to the ground and 5-volt on the on the Arduino. And for our GUI input, for all this, if you try to read data or do other calculations without values being calculated first, it'll give you some errors. So it'll tell you to calculate periods first, or for read data, calculate the 0 point first, and so on. So first we'll measure the 0 when the pendulum is in a resting position. So we'll go ahead and click this button right here. And it says click OK to measure 0 point. It's already in resting, so we'll click OK. It says it's about 9 centimeters, which looks about right. Then now we can go ahead and read our data. And here, if we try to enter nothing for string length, it'll pop up with an error as well and tell you to enter a number greater than 0. So right here, the string length is about 22 centimeters. So we'll go ahead and put 0.22 since the units are in meters for ultrasonic sensors. And we'll hit OK. And then it gives you some time to get the pendulum swinging before you actually measure the data. So we'll do that, click OK, start measuring data. And we'll keep the string length the same for all of these right now, just to make the video a little bit shorter. We can go ahead and start swinging our pendulum again, click enter to measure. And we'll do this for 7 string lengths. Get through this really quick. Again, we're just using 22 centimeters for each string length just to make the data collection a little quicker right now. Do 2. If I can type, do 2. Okay. String length 6. Measure 6. And last but not least, string length 7. I can measure 7. All right, now that we have that, we can click Get Theoretical Data, which will use the formulas that were provided in the project in Euler's method to calculate the theoretical time and distance values and period and string length values for the pendulum. And we can see here that table of data inserts all of our string lengths and our pendulum distance values for each one. Same thing with the theoretical data. It'll insert the string lengths and the theoretical pendulum distance for each one as well. And for periods, we have to calculate this using G input. So we'll click Get Periods. And here it'll use 3 points to find 2 zeros that are approximately 1 period away from each other. So we'll click here, here, and here. And we'll do this for all 7 string lengths. So there'll be 7 graphs that pop up that you have to use the G input for. Try to get through this pretty quick. I'll do down here, here, and here. Awesome. And you can see once we finished all of those, it'll calculate the periods and the theoretical periods for each of them as well. And then right here, the theoretical periods are all the same just because the string length is the same for each one. But with our saved data, it'll be different. Now we can calculate this best fit model, which will represent the string lengths versus period. We can go ahead and plot the pendulum distances versus time. Can see here that our measured data is this red dotted line, which is why it's a little bit more variable. And our theoretical is this smoother sine wave right here. It calculates that for all 7 string lengths. And here we can see, right now it's just a straight line because the string lengths are all the same. And then we can calculate our gravitational constant using this button. Again, data is not really that great right now because the string lengths are all the same, but we can also use this save load button up top. So right now I already have the good save data in the file, so I'll just click load save data. And it'll update our tables accordingly. And then click get theoretical again. Awesome, and you can see that the theoretical data has switched to the correct string lengths from our previously measured data. So this is the good data that we had collected before. And now we can go ahead and plot this good data. All right, here we go. So we'll do that for all 7 string lengths once again. And then let's click get theoretical. And here, we're gonna have to do the get periods once again, just for our good data, just so I can show you the string length versus period, just so I can get the correct graph up there. I'll do this once again for 7 string lengths. And this one, it's spiked a little bit here, but we'll use these values down here that are a little bit better. All right, now we can calculate best fit model again. And now we can see that the theoretical pendulum periods versus string lengths correctly shows that the longer the string length is, the longer the period is for the pendulum. Same here with our measured. You can also see that the longer the string length is, the longer the period of the pendulum is. And now we can go ahead and calculate our grav constant. And it's a little bit better right here, but the pictures and stuff that we'll show in the actual report and whatnot will show the better grav constant when we calculate the G input just more accurately, just because there I was rushing a little bit just to get the video shorter. And then up here, we also have, you can load string length distance and data from a file if you want to, and also time data from a file.